In this unit, we are going to talk about the integers, the set Z. The objectives that we pursue are basically to remember the definition of the set of integers, understand what an integer is, explore the operations within Z, and comprehend the properties of these operations. We will take a closer look at the computation of operations in Z, which is important due to the added complexity introduced by the use of signs. The requirements for this unit include a basic understanding of natural numbers, how they are operated upon, and their properties. What is the origin of the integers? Like many new numbers, the origin comes from attempts to solve practical natural problems, which we present here in the form of an equation. What is the solution to the equation 4 plus x equals 3? In other words, how much must we add to 4 to reach 3? Does this question have a solution? The solution to this question is that if we only consider natural numbers, there is no solution, because we can see that we don't need anything to reach 3. But instead, we need to subtract 1. The idea that we don't need anything, but we have an excess, is what makes us change and add the sign. Therefore, to solve this equation, we define the number. X equals minus 1, so we have 1 left over. We don't need to add, but to delete 1. This is the significance of the sign. In different problems, the negative sign can have different meanings, but it represents a change in the direction of what we need or what it exceeds. The general definition of integers includes the set of natural numbers as well as those natural numbers with a change in the symbol: 0, 1, minus 1, 2, minus 2, 3, minus 3, and so forth. The operations defined in Z are essentially extensions of those that already exist in the natural numbers. First, let's consider addition. How do we add integers? Let's examine it in various cases. If both integers are natural numbers, how do we add them? We add them just like we do with natural numbers. For example, 2 plus 3 equals 5. However, if both numbers are negative, meaning they are natural numbers with a negative sign, we first add the natural numbers and then change the sign of the result. For example, minus 2 plus minus 6, we add 2 and 6, and then we change the sign. That is minus 8. What happens if one is positive and the other is negative? So, how do we do the operation? Well, in this case, we subtract the natural numbers, making sure that one is greater than the other, and then we use the sign of the greater number. For example, minus 2 plus 6, what we do is take the sign of the larger number, which is 6, which is positive, and then we subtract 6 and 2, resulting in 4. With the sign of the larger number, which is positive, we get plus 4, or what is the same, 4. Another example, 4 plus minus 5. We subtract 4 from 5, which gives us 1. The sign of the larger number, in this case, is minus 5, negative. So, it's minus 1, resulting in a negative value. Another important operation in integers is to perform multiplication. To do it correctly and avoid errors, it's essential to have a good understanding of the rule of signs. We want to emphasize this rule because it is in these types of details that many errors occur in the early stages of the degree. The rule of signs dictates how two signs behave when multiplied, and it is quite simple. If the two signs are the same, both positive or both negative, the result is positive. If there's a sign change, one is positive and the other is negative, or vice versa, then the result is negative. So, how is multiplication done? Now that we know the rule of signs, well, first of all, as before, we multiply the associated natural numbers, and then we apply the rule of signs to the two signs. This way, minus 2 times minus 5 would be minus times minus and 2 times 5. Minus times minus is positive, 2 times 5 is 10, and therefore 10. 7 times minus 3, plus times minus, 7 times 3. The plus times minus gives us minus. 7 times 3 is 21, and therefore the result is 21. Minus 4 times 2 would be minus times plus, 4 times 2. Minus times plus results in minus, and 4 times 2 is 8. So the result is minus 8. We will now review the properties again. As you know, natural numbers possess the first properties listed in this table. These operations are associative and commutative, and they also have a neutral element for both addition and multiplication. Natural numbers satisfy these properties for both operations. In the case of Z, due to the definition of both the new numbers and the new operations, these properties extend to the whole set of integers. Therefore, we have that the set of integers satisfies the associative property, the commutative property, and the property of the neutral element. The distributive property is also satisfied, which is the one at the bottom. It is the product with respect to the sum. What differences are there? And let's say what is important and why do we need to remember the properties of the integers? Let's say that these same properties hold for the natural numbers. What differences can we find here? Well, the difference lies in the existence of the symmetric element. In fact, the search for the existence of a symmetric element is precisely the motivation for the creation of integers. Adding the negative numbers results in every element having its opposite. For a given number a, there is a number called minus a, called opposite, and it satisfies the property that a number plus its opposite equals 0. A number plus its opposite yields the neutral element of the operation, which is addition. For example, if we start with the number 2, its opposite would be minus 2, and if the starting number is negative, like minus 5, its opposite would be 5. We always change the sign of the number. The other property that we have here is the property of the symmetric element for the product, but integers do not possess that property. The only element that fulfills it is the neutral element. When a set of numbers, or a set with two operations such as these, fulfills these properties, it is said that it is a ring. The existence of the symmetric element in the sum allows us to define subtraction. How can we subtract two numbers? Well, given one number and another that we want to subtract, we leave the first number as it is and add its opposite. We are going to see a couple of examples of this. For example, 3 minus minus 2 would be the same as adding 3 to the opposite of minus 2. The opposite of minus 2 is 2, so it is 3 plus 2, which equals 5. If we are subtracting two negative numbers, like minus 5 and minus 2, the operation is performed in the same way. Minus 5 plus the opposite, which would be the opposite of minus 2, equaling 2. So it's minus 5 plus 2, and following the previously mentioned operations, it results in minus 3. One last example, minus 12 minus 5. To minus 12, we would add the opposite of 5, which is minus 5. Since both numbers now have the same sign, we take out the common factor, which is the minus sign. This results in the sum of the natural numbers, 12 plus 5, giving us the result of minus 17, which is the desired result. Well, up to this point, we have covered in this unit the definition of integers and their origins. We have also discussed the operations involving integers, explaining how to use signs correctly. And finally, we have discussed the properties of the operations within the set of integers. That concludes this unit. Thank you.